Hello everyone, welcome to this tutorial on one of the most popular memory virtualization techniques called paging. Before describing what paging is, let me first explain all the components. Let us start by taking a look at the physical memory. Here we have 8 memory blocks labeled P1 to P8. Each of these blocks is what we call a page. Processes running in a system have their own virtual memory. For our example, we have 2 processes. The virtual memory of each process is also divided into pages, which is labeled V1 to V8 for both the processes. Every process also has an associated page table. The page table maintains a mapping of virtual pages to physical pages. It helps the system keep track of which virtual page is mapped to which physical page for every process. Now let's take a closer look at these pages. Each physical page matches a virtual page in size. For our example, both the pages are of size 4 kilobytes. Now let us talk about what paging is. Paging is a memory management scheme that eliminates the need of contiguous storage locations. It allows the physical address space of a process to be non-contiguous, making the memory allocation job easier and process execution more efficient. In simple terms, it is a system that lets programs use memory in chunks instead of one continuous block. Let us see how these memory spaces interact. When a process needs to allocate a page in memory, a request is sent. For instance, here we have a new page allocation request from process 1. When the system grants the request, the virtual page, say V1, is mapped to a physical page, say P4. This mapping is then recorded in the process's page table. Like this, we can get multiple requests for allocating page memory, and for each request, a virtual page is mapped to a physical page and an entry is made in the corresponding process's page table. A process can also release a page when it is no longer needed. In this case, the system clears the virtual page in the process's virtual memory, the corresponding physical page in the physical memory, and then removes the mapping from the page table. For instance, here P1 releases page V1, so V1 is cleared from the virtual memory. The mapped physical page P4 is cleared out from the physical memory, and the corresponding entry is removed from the page table. This back and forth continues as processes request and release pages, making optimal use of the limited physical memory at our disposal. And that is it for today's tutorial on memory paging. I hope you found it informative and helpful. If you enjoyed this video and found it helpful, please hit the like button. If you have any questions or thoughts about memory paging, feel free to drop a comment below. And don't forget to hit subscribe to stay updated on my latest content. Thank you so much for watching.